Hello my dear JEE warriors, so sorry for the delay for starting the class because I was just planning your revision class for the final lap for the next week, and there is some amazing surprise coming up for all of you for the final 2 weeks. Okay, in case you have missed any of the classes in the last week or this week, please make sure you watch them. I had completed wave optics. There were numerous classes of chemistry as well as mathematics which were conducted, so please watch them. So today we have reached to gravitation, and tomorrow not at 11 o'clock, this is going to be in the evening at 5 o'clock. So make sure you attend the high weightage predictable paper of sure short series. All right, so that is tomorrow, and today is gravity. Nice to see all of you out here. Hello, good evening. Yes, looks like I'm audible as well as visible. Yes, Black Ops, hello Anandu, hello Madhubanta, hello Anandu, hello Abhinay, hello everyone, welcome aboard. So today we are going to see the concepts which are important from gravitation. We are going to see the questions and the PYQs as well as the tips and tricks as well. Now as we do this session, remember this particular topic of gravity carries 4 to 8 marks of weightage. Most of the shifts get around 2 questions, either directly or indirectly. Many of the shifts also get 1 question, but 1 question for sure you will get, and this is a short and sweet chapter, so I feel that you must do this particular chapter. Yeah, right. So let's begin with the gravitation chapter. So starting off with the concept of gravity, remember any two masses, let's say this is mass m1, this is mass m2, no matter what is their separation between them, they will always attract each other. They will never ever repel. There will be always some kind of, yes, there will be always some kind of a force. This force is always going to be attractive in nature, which we call as the gravitational force between any two masses. The beauty of this force is that apart from being just attractive, if there is mass m1 over here and there is mass m2 over here and there is some force between them, let's say I call it as F, then even if another mass, let's say m3 comes, this F is unaffected by m3. This F is unaffected by mass number 3. This has no role to play in these two people's forces. Okay, it is unaffected by them. In fact, m3 will apply a new force on m1 as well as m2. As simple as that. So there will be more forces coming up over there. Hello Patujio, hello Shavanan, hello Jarvi, hello Hope, welcome Teja, hello Atharva, welcome aboard. And this mass, even if it comes in between, does not matter. Also interesting thing to note is that these forces between these two masses are always along the line joining these two masses. So these forces are always along, the force is along the line joining the masses, keep this in mind. Okay, and this force is always going to be attractive. This is particularly important because in magnetism you have seen, or you would have seen, that the forces may not be along the line joining the charges or anything. The charge is moving somewhere, you use cross product and the force only acts in some weird direction. But in gravitation that is not the case. So talking about the value of the gravitational pull between two masses, m1, m2 separated by some distance r, remember whatever force acts here, the same force acts here by Newton's third law. If you call this as action, this would be the reaction. This is using the third Newton's law of motion. And this force is nothing but G m1 m2 divided by r square, where G is the universal gravitational constant whose value is 6.67 into 10 to the power minus 11, right? So this is your G. Now this is for two masses, but if there are more than two masses, let's say there is a mass m over here, and there is a mass m1, there is a mass m2, there is a mass m3, and so on and so forth. Then what we will do to find the force on m because of all these masses, you draw lines joining these masses, and each mass will independently apply forces on that mass. Let's say this is F1, let's say this is F2, let's say this is F3. So the net force on M is given by F is nothing but F1 vector plus F2 vector plus F3 vector, where each of this force will be like M1 divided by R1 square, where R1 will be this distance. Then you will have R2, then you will have R3. What is this principle called? This principle is basically called as your superposition principle. Okay, which basically says that when there are multiple masses acting, multiple masses placed around you, and each mass will pull by their individual forces F1, F2, F3, etc. You take the vector sum of all the forces to find the net gravitational pull. That is what this superposition is all about. So all these pointers I have also mentioned over here. Force always acts along the line joining the masses. It is always attractive, never repulsive. Gravitational force is conservative in nature, meaning that if gravitational force changes the energy of the system, then the mechanical energy will be conserved. Yes, kinetic energy might change, but potential energy will also change to adjust itself so that the sum will remain constant. Gravitational force between the masses is independent of the medium. Like I said, if you put a mass in between, does not matter. If a mass is present somewhere, doesn't matter. If a collection of masses or medium is present, doesn't matter. The gravitational force stays intact. It is not dependent on what is there around it. Also, the force value is G m1 m2 by r square, and this force are mutually equal but opposite, and they act on two different bodies. If one is action, the other is reaction by Newton's third law. That's what I told you. Okay, and I told you about the principle of superposition as well. So let's see some questions. Now today I have got some questions for all of you. Yes, does the NCERT cover theory part for JEE Mains? Most of it, yes, Alia. Is this chapter is dependent or independent? It's a almost independent chapter. Only few things will be required, like basic idea of angular momentum, basic idea of energy, basic idea of Newton's laws should be needed. Otherwise, most of it is independent only. Okay, so this is a previous year question. Two identical particles, each of mass m, go around a circle of radius a under the action of mutual gravitational attraction. The angular speed of each particle will be. I am taking it from this particular book. So in case you are not aware of this particular book, let me tell you, this is your JEE Mains PYQ book of all the 46 papers of the last 2 years. So because a lot of students think that I should solve 1990s question, but they don't end up solving 2022 or 2023 questions, which are more relevant for 24 or 25 aspirants. So this is a question right over here. This is the 36th question. You can see it's there on page number. If you are already having the book, you can see it is already on the page number 37, right? It's there on page number 37. So let's solve this particular question which is there from this particular book, and let's see what the answer should be. Well, since these two particles go around in a circle of radius r, in a circle of radius a under the action of their mutual gravitational attraction, the angular speed will be how much? Well, see, these two masses, because they are identical, because these two masses are identical, right? Their center of mass will be exactly in between. Their center of mass will be exactly in between, and the center of mass will be at rest. The center of mass will be at rest. This particle will go around like this, and at the same time this particle will go around like this. The radius of that circle is nothing but given to be a. The radius of the circle is nothing but given to be a. Now why are they going in circular motion? Because there is gravitational force which provides the centripetal acceleration. There is gravitational force which provides the necessary centripetal acceleration. Are you able to see that? For any particle to go in a circular path, what do you need? You need centripetal force. Who is that centripetal force? The gravitational force here. And what is it doing? It is accelerating that particle towards the center. It's accelerating towards the center. Yes, very good. So now if I use Newton's law and say F is equal to mass into acceleration, force is mass into acceleration, force is mass into acceleration. You write it for this or this, it's one and the same thing, it won't change. What is the force? A lot of people will say gmm by a square. Wrong. The distance between the two masses is 2a. Observe carefully, this m and this m, diameter separation, a plus a is 2a. So the force will be g m1 m2 divided by 2a's whole square. 2a's whole square is equal to mass into acceleration. Because we want to find angular speed, why not write it as omega square r? R is the radius, which is itself a, Now you will see many things will get cancelled. M gets cancelled. A will come below. So I will get omega square. What will I get omega square equals to? Think about it. I'll get it as gm by 2 square is 4 into a square, and this a will also come. So what will omega be equal to? Root of gm by 4a cube. Root of gm by 4a cube. Is it there somewhere? Many of you have started marking the answers correctly. Very good. The answer is root gm by 4a cube. That's how this question was supposed to be solved. These kind of questions do come in the examination. Now remember, do you categorize this question as a gravity question? Yes, maybe 60% to 70%. But it also has maybe 10-20% or 30% concept of circular motion, because centripetal acceleration is involved. Maybe 5-10% concept of Newton's law, F is ma, right? So that's why I say gravitation is an important chapter. Sometimes you might get up to 2 questions in your examination. It will give you 8 marks. It will decide whether you get computer science or not. It will decide whether you get a top NIT or not. Okay, so don't leave this chapter. It's a very small and sweet chapter. Now the same question can be also asked for 3 masses. This kind of question has also come in the JEE Mains paper. You can see it again. Okay, so when there are 3 masses and they are moving in a circle, sometimes there are 4 masses, sometimes there are 6 masses. Basically any regular polygon they can give you. They can give you any regular polygon. All right, so let's have a look how to solve these kind of questions. Again, this is mass m, this is mass m, this is mass m. They are all going with same speeds because they are identical. The question is, what is the speed? The question is itself, what should be the speed? This is v, this is also v, and this is also going with speed v. Now their center of mass will be somewhere over here. The center of mass will be at rest. The center of mass will be definitely at rest, and any mass that you see will be going in a circle of radius r like this. This will be r, even this will be r, and even this will be r. So let me call this as r over here. That is the radius of the circle along which these particles are going. And each particle will experience gravitational pull from 2 other masses. One mass over here and another mass over here. Because they are identical, their magnitudes are also same. So if I call this as F1, I have to call this also as F1. Now these two forces resultant will be the centripetal force. Nor F1 nor F2. Nor F1 nor F2. Which I don't spam. You can watch my old Zero to Hero or Nurture series. Both F1 and F1 together, their resultant will act like the force providing the centripetal acceleration. Where will the resultant be? Obviously, since they are equal, it will be on the angle bisector. Because the forces are equal, won't it be on the angle bisector? Is that concept very, very clear? Very good. So how much will that net force be? So if I show that net force over here like this, so I can say F is net of the two F1s, that F will be root of F1 square plus F1 square, a square plus b square plus 2ab cos angle between them. What is the angle between them, these two forces? Obviously it is 60 degree because it is an equilateral triangle, so it will be cos 60 degrees. It will be cos of 60 degrees. You can see F1 is common from everywhere, and you will have 1 plus 1 plus 2 into cos 60, which is 2 into half, which is again 1. So it will be F1 root 3, but F1, force between any two masses, will be nothing but GMM by a square, and this will be root 3. So that will be your F1. That will be your F1. Oh, sorry, not F1. That will be your F, the total force on any one of the particles. Now understand that force what I got, will be mass into centripetal acceleration. So I can use this, which is gm square root 3 by a square. Gm square root 3 by a square, that will be the force, is equal to mass into centripetal acceleration will be omega square r or v square by r. So I can use v square because I want to find the speed. So the question is, what is the radius? You will have to find the radius separately and only then solve the problem. You will have to find the radius and only then solve the problem. Come on, quickly think, what will be the radius for such a situation? This is an equilateral triangle. This is the radius which you have to find, and this is the center point. And if you extend it further, it will become the altitude, it will become the perpendicular bisector, it will also become the median, because this is an equilateral triangle. So this also becomes the centroid. This also becomes nothing but your centroid. And the altitude, I can find it in terms of this. If this is A, this is 60 degrees, then I can just say that the altitude, which is this complete height, will be nothing but A sine of 60. It is the sine component in this particular triangle that you see. It is the A sine of 60, it is opposite. So it will be A root 3 by 2. But I don't want the altitude, I want R. And we know centroid divides the entire thing in the ratio of what? 1:2. Everybody remembers this? This is 1, this is 2. This is 1, this is 2. So come on, my dear warriors. So what will R be? So the value of R will be 2/3 of the altitude. Because G divides in 2:1 ratio. The centroid G divides in the 2:1 ratio. So 2 by 3, what is the altitude? It is nothing but A root 3 by 2. 2 cancels. I will get this as A by root 3. This calculation is there in many problems. So you should know this standard calculation. Now use this radius over here. Use this radius of A by root 3 over here. So use this as A by root 3 over here. And now just solve this. You can see many of the terms get cancelled, like one of the mass here, one of the mass here, one of the A over here, one of the A over here. So take this on the upper side. So G into M into root 3 divided by A. This will go on the top. This will become root 3 V square. Correct? And you can see root 3 cancels, and therefore V will be root of GM by A. V will be nothing but root of GM by, very good Dinesh, awesomeness, proud of all of you if you have got till here. Okay, so there is some bit of geometry or trigonometry involved in these questions. There is knowledge of vector addition which is needed in these questions, and obviously the knowledge of gravitational force is only here. Only this part is gravity, rest other things are from other chapters. So you can have questions like I said before, you can have for 4 masses. This can also come in your JEE examination. You can also get for 6 masses as well. Just that you should know how to add using vectors, you should know how to use circular motion, and you should be able to understand the geometry. Is that okay, everyone? Will you be able to do it? If more such questions come, give me a thumbs up and smash the like button. Give me a thumbs up and smash the like button, then we'll go ahead. Okay, so in case you do not know about this book, please make sure you check out the link which is there in the description box for getting the previous year questions of JEE Mains from all the subjects, all the chapters arranged systematically, and the solutions are in detail. Okay, so you can check it out. Like I said before, we are taking up the questions from that book as well today. Okay, let's go to now gravitational field, gravitational potential energy, and the relationships. This is a very, very important topic. Now, if you take a mass and at some separation there is another mass, we know that this mass will get pulled by this mass over here, and this mass will also pull this mass over here. But imagine there is nothing around capital M. There is nothing over here. There is nothing over here. Then there will be nothing to pull. There will be nothing to pull. So there won't be any force. But the moment somebody brings that mass M from infinity, this M is, let's say, at infinity, somebody makes this mass come over here, suddenly this mass experiences the force. So the question is, how did the mass know? How did small m know how much force it will be pulled by? It will be pulled by. How did it know that there will be a force over here? How did it know that there is a mass over here? That means even before this mass was present over here, there was something else which was present, which was not a force but a kind of an information, that if you stand over here, you will be pulled by this force. If you stand here, you will be pulled by maybe lesser force. If you stand close by, then you will be pulled by even more force. So there was some piece of information which was present even before that mass existed. That is called as field. That is called as, what is it called, my dear students? That is called as the gravitational field. So gravitational field is nothing but the information, is nothing but an information that, okay, you will experience so much and so force if you stand here or if you stand there. Yes. So my dear students over here, in general, if you have masses or collection of masses and you are standing at any point, then at that particular point, the gravitational field, gravitational field is given by the force of gravity, per unit test mass, meaning you bring a testing mass over here, let's say it is M. On that mass there will be some force, let's say I call it as F. Then that force divided by that test mass is that gravitational field E, field E. So E value is in the same direction as the force. This is a vector quantity. E1, this is a vector quantity. E1, that is a vector quantity. Yep. Yes. It's buffering. I don't think so. Just check it out. It should be fine, bacha. No, it's fine. Just check it out. Yep. Okay, great. Cool. And the unit of this will be Newton per kg. Newton per kg will be nothing but the unit of the gravitational field. It is a vector quantity in the direction of the force on the test mass. In fact, if you take a point mass over here, if this is a point mass over here, you will see that at this point, if you place a test mass, the test mass will get pulled this much over here. So this is the direction of the gravitational field. If you stand here also, the mass will be pulled in this direction. So this is the direction of the gravitational field. If you stand here, this is the direction of the gravitational field. If you stand here, this is the direction of the gravitational field. If you stand here, you will be pulled towards the mass. If you stand here, you will be pulled towards the mass. Here, towards the mass, towards the mass, towards the mass. As you go far away, the pull will reduce, but the direction is always towards that mass, So if you happen to join all these lines, if you happen to basically join these lines over here, if you happen to join these lines over here, something like this, 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 okay, something like this. These are nothing but called as the field lines. Okay, so these lines show in what direction the gravitational field is acting. And also realize that the gravitational field lines always terminate on the masses. They can never originate from the mass. In electrostatics, electric field lines can originate if it is a positive charge. It can terminate if it is a negative charge. But gravitational field lines always terminate on the masses. They can never ever originate. It's okay, Praveen Kumar, even if you're late. Hello, JEE. Jamkai, welcome aboard. Yep. This is about your gravitational field, which is force per unit mass. This also tells me that if by chance there is a gravitational field line like this, there is a gravitational field lines. These are your gravitational field lines like this. And by chance you happen to place a mass over here, then that mass will experience a force. Given by the mass multiplied by the field vector at that point. Mass into field, because remember field was newtons per kg. So if you take the mass over here, it will just become mass into the field will give me the force. And this force, remember, this force, the force is always tangential to the field, is always tangential to the field. Keep this in mind. Is always going to be tangential to the field. Very, very important. Right? Very good. Okay. Clear to this point? It will not act opposite. In electricity, it was like that if the charge is positive, it is in the same direction. If the charge is negative, then it is in the opposite direction. Here, there is no such problem. It is always in the direction of the field. Now, let's talk about the next concept, that is potential energy, and then potential, and then we'll see how are they related to each other. So talking about potential energy of gravitation. When you have a collection of masses, you will see they have ability to perform work, and that ability to perform work defines that they have some gravitational potential energy. How do I know they have ability to perform work? You leave them. There will be gravitational pull. They will start moving towards each other. So they acquire kinetic energy. Where did this kinetic energy come from? Obviously, it was stored in the form of potential energy somewhere. So that was the gravitational energy. So the moment you release these masses, they start moving towards each other, right? They might start colliding with each other. So that kinetic energy has come from the potential energy. I hope that is clear. Yes. So my dear warriors over here, if there is a system, this is a system of masses, this is a system of masses. If I take these masses really far away, if I take these masses really far away, meaning they are outside the universe. If this is the universe, they are on the boundaries or really far away. I can say really far away. They are really very far away. Okay, hardly any interaction. When they are really far away, there is no interaction, and the potential energy for such a scenario for infinite separation is always assumed as 0. This is also called as your reference potential energy. When their separation is infinite, they are on the boundaries of the universe or outside the universe. These masses do not know who they are. They do not know where the other mass is. The separation is so far, the forces are negligible, so you don't know about other things. So that case, I will assume that they have no potential energy, and that is 0 potential energy, 0 reference. You always measure potential energy with respect to this value. You always measure potential energy with respect to this value. Now, at this location, you can see their separation is not infinite. They are not very far away. In fact, they are close by. So in this situation, the potential energy will definitely not be 0. In fact, can you guess the value? Will it be positive or negative? Will it be positive or negative? Think logically. If these masses are slowly brought inside the universe and then left, there will be a small weak force of attraction, and that weak force of attraction will start pulling these masses, and slowly they will start accelerating and they will acquire kinetic energy. Where will that come from? That will come from potential energy. So potential will get converted into kinetic. So the potential will keep decreasing as they come close by. The potential energy will keep decreasing, and you will see kinetic energy will keep increasing. Potential will keep decreasing, kinetic will keep increasing as they come closer and closer, as they get more and more speeds. So think about it. If potential is decreasing, what will it be? It's going to go lower than 0. Hence the potential energy will be negative. Hence the potential energy will be negative. Is this concept clear? Is this concept clear? I have explained it to you in a very simple manner without any mathematics. That's the idea behind this. Okay. And this potential energy is defined as the work done to basically assemble the charges, or sorry, assemble the masses. Okay, it is nothing but the work done to assemble the masses. As simple as that. That is your gravitational potential energy. Obviously, it is a scalar quantity. It is only in joules that you measure it in SI units, or basically ergs in CGS unit. Now, when you take 2 point masses and you do the calculation for 2 point masses M1 and M2, the gravitational potential energy formula comes out as minus G M1 M2 divided by R, not R square, R, and there is a minus sign because, like I said, the gravitational potential energy will always be a negative value. Always. The gravitational potential energy will always be a negative value. So, say for example, there are 2 masses over here, M and 2M, and their separation between them is A. Now, I make their separation 2A. Okay. So, question is, how much work is done by the external agent? How much work is done by the external agent to change from here to here? So, from this to this, if I want to do, how much work do I need to provide? Obviously, I have to do work because I have to separate them. It's against their wish. They wanted to come close, like Pandu and Champa want to always meet like lovebirds, but you want to separate them out. So obviously you have to do some work. So that work which you are doing from external source or agent is going in changing the potential energy of the system, which is final minus initial energy. Final minus your initial energy, right? Now, what is the final energy? Minus G m 2m divided by distance, which is 2a, minus what is the initial energy? Think about it. Minus G m 2m divided by a. Now, if you notice over here, minus minus will become plus. You will have some things common like G into 2m by a, 2m square by a, that is common. And here you have minus 1 by 2, because this 2 is also there, plus here you have 1. 1 minus half, 1 minus half is half. Half, the 2 will get cancelled and you will get it as G m square by a. That will be the work done by the external forces. That will be the work done by the external forces. Is that clear, my dear warriors? Okay, great. Yes, yes. 11, we are discussing JEE questions here, not NEET. Yep. Another kind of questions that you usually get is where you have multiple masses, m1, m2, m3, m4, m1, m2, m3, m4, and then the scenario will be find the total potential energy. Find the total potential energy of the system. So what you do in such cases is that generally you will be given this distance, this distance, this distance, this distance, this distance, and let's say that distance is given to be a. Okay, so here when you want to find the total potential energy of the system, take two masses one at a time and take all the possible pairs. Like the total potential energy will be minus G m1 m2 divided by this distance, which is a. Then take this pair, minus G m1 m2 divided by a. Then these two masses, G m1 m2 divided, sorry, this is not m1 m2 again, my bad. This is m2 m3. This is m2 m3 divided by a. Then this is G m3 m4, m3 m4 divided by a. Lastly, this is G m1 m4 divided by a. So this pair is done, this pair is done, this pair is done, this pair is done. What else is remaining? These two and these two. So again, minus G m1 with m3, m1 with m3, but the distance won't be a, be careful, distance won't be a. This distance or even this distance will be root 2 times of a. Why is that so? Why is that so? Because if you have a square, and if you draw a diagonal, if this is a, this is a, how much will this be? This will be root 2 times of a by Pythagoras theorem. By Pythagoras theorem, correct or no? So won't this be root 2 times of a? And same thing between m2, m4. So G m2, m4 divided by root 2 times of a. Divided by root 2 times of a. Yes, this is a common mistake which many students do. They forget that root 2, they write it as a. Always take all the possible pairs. All the possible pairs. So if there are 4 masses, you will get 6 pairs. If there are 3 masses, you will get 3 pairs. Basically NC2. If there are n masses, you will get NC2 pairs. Obviously by logic of combinations. Okay, so we have learned what is potential energy, what is the meaning of field, how to calculate force, how the field lines look like. Now you also get another term called as potential. You get another term called as gravitational potential. Gravitational potential. The symbol is V. Many students get confused. What is the difference between potential and potential energy? Okay, I'll give you a simple example. Right now, do you have the ability to get 99 percentile in maybe second attempt, if not the first attempt? Obviously the answer is yes. If you're thinking or doubting, What are you asking, sir? No, I don't think so. I'm not that a good student. I think you are overestimating me. I feel that no, it is possible. Even by some tricks and logic, you can even achieve 95 percentile even if you are getting 60 to 70 percentile scores even right now in the last 2 weeks. You watch my strategy videos and there will be more such sessions where I'll be conducting sure shot series, predicted paper, replica paper, all these things. There you will understand how the questions are, and if you follow my strategies smartly, you can easily get 95 plus even with 60 percentile scores which you had before. If you're scoring 90, 100%, 99 you can get even in the last few weeks. So do you have the ability? Answer is yes. Will you get it? That depends on how you perform. So that is exactly the difference between potential and potential energy. Potential energy is what the energy is possessed because of its situation, because of its condition, because of its arrangement. Potential is the capability of getting that energy. It's the hope that it will get that energy when you place it. That's the main difference. So just like over here in field, you had only one mass. Imagine there is just one single mass over here. There is nothing present at this particular point. So the potential at point P is defined like this. It is defined like this. It is nothing but the work done to bring a test mass, from infinity to that particular point, the whole thing divided by the value of the test mass. Now potential value is nothing but V, this numerator, work done to bring the test mass from infinity to P, work done to bring the test mass from infinity to P, work done to assemble the masses. Exactly, that is nothing but U. So that's the reason why you will get this as U divided by the test mass. So maybe this was the test mass which you got from infinity over here. You got it from infinity to this particular point. So you put it over here, U by M. That is gravitational potential, and the unit of gravitational potential, this is joules, this is kg. So it will be joules per kg. A very, very important formula. More than this, what you will be ending up using is this formula. Shift the mass over here. So you will therefore get U is equal to your V times of M. Now you put the delta symbol. Change in energy, mass won't change, is change in potential into times of mass. So from this you will get delta U will be equal to delta V times of mass. Delta V times of mass. This is a very, very important relationship. You would have seen such a relation even in electricity. Change in potential energy is potential difference into charge. Here it is potential difference into mass. That's all. That's the main difference that you see if you compare it with electrostatics. Exactly, black caps. Yes, exactly. Very good. Yes, Ajay Kumar, if you complete those 20 chapters or whatever chapters I have given to all of you for getting 90 and 99 percentile, you can get a really good score from the YouTube videos as well, and the mock tests that we are conducting free of cost. And yes, if you are solving PYQs from this book, trust me, you will definitely get it. Definitely. Okay. So that was gravitational potential. It is the work done to bring that mass at some point divided by that mass. And that is the relationship between potential and potential energy. So now you might be wondering, okay, so if I have to summarize all of this, force was G m1 m2 divided by r square. Potential energy was G m1 m2 divided by r with a negative sign. When we go to field, it was force per unit mass. So the formula becomes Gm divided by r square. The formula becomes Gm divided by r square. So what I'm referring to over here is, if I just have a point mass, m, then at a distance r from it, the gravitational field which will be forced by that mass will come out to be Gm divided by r square magnitude wise. It will not have m1, m2 because this is test mass, understand that. So even if you put that test mass will get cancelled. Okay, so if you put test mass over here, you will have to divide it by the test mass. So it will become Gm divided by r square. Gm divided by the r square, right? That's the formula for the field due to a point mass. Similarly, what will be the potential? It will be U by m. So it will be nothing but minus, but this m is the test mass. So minus Gm mt divided by r. Mt is there over here. So you will get it as minus Gm by r. So the gravitational potential will be minus Gm divided by r. So all the terms are over here. You can see force has the maximum terms. m1 is there, m2 is there, r square is there, right? If you go to energy, one of the r goes. If you go to field, then one of the m goes. If you go to potential, r also goes. From r square it becomes r, and that m1, m2 will just become one single mass. So you can see potential has the least terms, force has the most terms. In energy, r is gone. In field, one of the mass in the numerator is gone. Are you seeing that, my dear warriors? Very good. And how do I go from here to here or here to here? We have seen that. If field is given and I want to go to force, or force is given, I want to go to field, then I will use nothing but mass times the field. Mass times the field is nothing but the force. Same thing for here to here also. The mass times the potential will be nothing but the potential energy, or change in the energy is mass times potential difference. That is how you go from here to here, or here to here, or here to here. Can you go from here to here, or here to here, or here to here, or here to here? The answer is yes. What is the relationship that you will use to go from here to here or there to here? The answer for that is what you have learnt in work energy for conservative forces. Can somebody tell me, my dear students, what was it that you have learnt back then? Yep, F is minus du by dr. You have learned this relationship. So you can go from here to here using this relation. So naturally, if you want to go from here to here, also you can use this relationship. Instead of force, you will have field, and this will be minus dv by dr. It will be minus dv by dr. Yep, very good. Yes, can we watch your lecture in 2x? Yes, definitely. So for watching my lecture in 2x, what you need to do is, you need to make sure that you use Einstein's relativity principle. So what happens using that principle is that when you run, or when you go at a very high speed, then time dilation happens. So the time shrinks. So this current class might shrink to, a double speed if you go at very, very high speeds. So you can calculate that using the formula, that time dilation formula, which is delta t is equal to delta t divided by, root of 1 minus v square by c square. So that is the formula you'll have to use to find out what speed you need to go to reduce my time, okay, to 2x in a live class. But in the recorded class, you don't have to use it. There is an option on YouTube where you can just click on 2x and you can watch it at 2x speed. Okay, cool. Chalo, let's move ahead and let's see if there are certain questions which can come on that concept of dv by dr, something like this. Imagine, like, say potential is given by x square. Then question is what is the field? Then what you will do, field is minus dv by dr. Here potential is a function of x, so you differentiate with respect to x only. So this will be minus derivative of x square. So it will be minus 2x. It will be just minus 2x. Is that clear? Outer layer. Chumma man. I hope you had fun. Okay, we have fun in the classes. Okay, so I hope you enjoyed it. All right, great. Next, if potential is given as x square into y cube, something like that, and then they ask you to find the field, then you need to be little bit careful because there are both x and y over here. In such case, ex will be found separately, ey will be found separately. Ex will be derivative with respect to x, ey will be derivative with respect to y with a negative sign. So when you differentiate this with respect to x, y will be a constant. So you can put y cube outside and you are differentiating only with respect to x. And over here you are differentiating with y, so x will be a constant. So it will be dy cube by dy. So this will become minus x square's derivative 2x, so 2y cube x, and this will be y cube's derivative 3y square, so minus 3x square y square. So the total gravitational field will be, this is x component, so minus 2y cube x I cap, this is the x component, and the y component will be minus 3x square y square j cap. This is how you get it. Is that clear? Is that very, very clear? Yep. So these kind of questions can also come in your JEE exam. So we have spoken about field, potential, etc. All these terms, and this was one of the most critical slide I feel, which relates all the terminologies. Now sometimes you might also get questions on conservation of energy. You might get questions of conservation of energy like say for example, you know, one mass is here, another mass is here, okay, and when they come close, okay, what is their relative speed? Here it's almost at rest, here it is almost at rest, and they are really, really far away, example, something like that. These kind of questions can come. The question will be, when their separation is a, what is their speed if this is mass m and this is mass m? So in these kind of questions, what you have to use is conservation of energy. Conservation of energy principle is usually used for these kind of questions, where in the initial state, when they are really far away, it will have some initial potential energy, it will have some initial kinetic energy, and when it comes close, it will have final potential energy and final kinetic energy. What will these values be? When it is really far, infinite separation means zero. So no potential energy at all. Far away, so when distance is far, no interaction, no energy, zero reference. And they are almost at rest, so no kinetic energy also. Potential energy wise, when their separation is a, potential energy will be minus gmm divided by a. Kinetic energy wise, each one will have half mv square, and this will also have half mv square. Half mv square plus half mv square is mv square, and I will put mv square over here, and I will take these people over here, so this will become gm square by a. Mm will cancel, mm will cancel, so what will I get v square as? What will I get v square as? I'll get it as gm by a, so v will be root of gm by a. So the speeds with which they are coming towards each other is root gm by a. Is that clear? Everyone with me? Understood? So these kind of questions are also common based on gravitational potential energy and conservation of energy principle. So all these things are put up in the slides also, so that later on you can watch it, okay, in detail. All right. So gravitational potential energy, gravitational potential, everything, relationship between them, everything we have discussed. So this is the next question, question number 7. So if you are using this book already, please make sure that you are opening up question number 7. It's already there. Okay, I think it should be there on page number 34. Yes, just open page number 34. A body of mass m is taken from Earth surface to a height equal to twice the radius. The increase in the potential energy will be how much? That's the question. Okay, let's solve this particular question, my dear warriors. Okay, let's try to solve this particular question, my dear students. Body of mass m is taken at a height h equal to twice the radius of the Earth. Okay, so this is the Earth at a height equal to twice the radius. This is where you take it. This is your Earth. This is the center. Okay, this is where the mass is. This is the mass of the Earth. It's as good as saying that you have kept two masses. You have kept two masses. Earth's mass as a point mass and this mass over here at a distance of 3r. It's at a distance of 3r. Isn't it? That's what you have done. And initially it's taken from the Earth's surface. So when it was on the Earth's surface, it's like having two masses. It's like having two masses separated by a distance r. So from this situation, I have got it to this situation. How many of you realized? Earlier the mass was on the surface. It's like two masses separated by r, because the Earth can be assumed as a point mass at the center. And when you take at a height 2r, the separation from the center to center will be 3r. So I will increase the separation. So the question is exactly that. What is the change in the potential energy? Delta U will be final, which is minus G, capital M, small m divided by 3r minus G m divided by r, right? That is what it is going to be. Let's see what do I get. I can see GMM divided by r is common. Here I have minus 1 by 3 plus 1. 1 minus 1 by 3 is 2 by 3. So this will be 2 by 3 GMM by r. Now the answer does not have capital M nor capital G. It has small g and small m only. So you have to play a small game over here. This was a mains 2023 question. What will you do? One way is you see where that 2 by 3 number is in the options. A not there, B not there, D not there, C yes it is there. So most likely it will be C. That's one way. You can use some common sense. Other thing is to play it safe. You can do one small thing over here. Just one second. Yeah. What is it? This delta U will be equal to 2 by 3. You can write it as Gm by r square, and then here you will put mr. The reason why I multiplied and divided by r is because I know what this term is. It is acceleration due to gravity. So it will become 2 by 3 gmr. 2 by 3 gmr. Yes, that is option number C. Yep. Small g is gm by r square. That is a substitution which you can do. That is the value of g. If you don't know, don't worry, we'll be coming to acceleration due to gravity in some time. There you will again see it. Okay, so that's how you can solve this JEE Mains 2023 question. These kind of questions are very common. That's what I wanted you to see. Look at this. Potential is a function of x and y. Find the field at this point. Also find the force on this point. Okay, straightforward question. Because potential is given to be 20x plus 40y, the gravitational field in the x direction will be derivative of this potential with respect to x separately, and in the y direction the field will be derivative of this potential with respect to y only. So when you differentiate with respect to x, this term will be constant. Constant's derivative will be 0. So I'll just have derivative of 20x by dx plus 0, because this guy will vanish off, and over here I will say that when I differentiate with y, x is a constant, so this guy will become 0, only I will have the derivative of 40y. So what do I get? X's derivative is 1, so it will be minus 20, y's derivative is 1, 40 with the minus sign. So I will get the total gravitational field will be minus 20 I cap minus 40 j cap. You can see it is independent of x and y coordinates. So here, even if the coordinates are given 2 and 4, it has no significance because the field is the same. It's a constant field. So that is the first answer. You don't even have to substitute anything. It's a constant field. There is no x and y variable in that after differentiation. Correct? Similarly, what about the force? What about the force? We know force is mass times the field. So mass is 250 grams, which is nothing but 1/4 of a kg, into the field, which is minus 20 I cap minus 40 j cap. This 250 grams is 1/4 kg. Mass into field is force. So 20/4 is 5. So minus 5 I cap. 40/4 is 10. So minus 10 j cap. So that many newtons of force will be applied on that particle. Okay. So this is also another kind of question which you can get. Very good. Minus 10 j, not plus 10, Harini. Yes, minus 10. Minus 10. Okay. So both are minus because, yeah, this minus sign is very important. That minus sign came from here. Now, you should also know the field potential formulas for different geometries. Be it not just a point mass. Point mass we have already seen over here. Point mass we just saw over here. Where did it go? Yes, for a point mass, we saw it right over here. Gm by r square and minus gm by r. That was for a point mass. But for other geometries also you should know that. For other geometries also you should know that. Starting off with the ring. Starting off with the ring. What and all things will be given in the ring? You will be given the radius of the ring, the mass of the ring. You will be also given how far you are on the axis. So at this particular point, you will be experiencing a gravitational field like this. Always field is attractive. Remember that. It will try to pull the test mass over there. This value of E is given by Gm divided by, here you will have r square plus x square. Here you have x over here. So this will be raised to 3/2. Raised to 3/2. This is the formula. And one way I remember this formula, that x is on the top, because if x was 0, just think about it. If x was 0, that means you are at the center. Each mass on the ring will pull it from all the sides like that, and they will get cancelled. So the net field will be 0. So by substituting x as 0, the field should come out 0. That's how I remember x is there in the numerator. Understood? Because the field will cancel. Okay. Now what about the potential formula? The potential formula is just minus Gm divided by, just you have root of r square plus x square. Potential will not cancel, don't get me wrong over here, because even if you are at the center, each point will apply potential. Each point will apply potential and they will just add up. In fact, there has been a question like this, where is this possible that the field and potential out of the two, both are 0, both are not 0, one is 0, one is non-zero, one is non-zero, one is 0. Come on, think about it and tell me. Which of the following are possible? Both 0, both non-zero, one is 0, one is non-zero, one is non-zero, one is 0. Are all 4 possible, or only few of them are possible? Yes, it is very similar to electric field, correct. Yes, if you remember electric field formulas, you also remember gravitational field formulas, correct. So, my dear warriors, in such cases, just visualize certain scenarios. Field is not there, potential is also not there. Yes, possible. This is possible if no masses only are there. No masses. Basically, it is completely empty. It is completely empty. Yeah, then it is possible. Definitely. 100%. Field is also there. Potential is also there. Yes, definitely. Example, due to a point mass. If you take a point mass and you are standing at some distance, okay, then you will see field is also there, potential is also going to be there. Field is there, even potential is going to be there. Yep. Now coming to 3 and 4, because many students get confused here. Potential is there, field is not there. I think this is also possible. I'll give you an example. Imagine one mass is here and another mass is here. Example, both masses are equal only. Example, both masses are equal only. If you stand exactly at the midpoint, what will happen? Exactly at the midpoint, this field and this field will cancel. So field will cancel, and it will become 0. But due to this mass, there will be some potential. Due to this mass, there will be some potential. Potential will be negative value plus that negative value. So it will be a big negative value. It will be a big negative value. So you will get a net potential. Yes, you will get a net potential. So this is also possible. What about this? Potential is 0, but field is not 0. In fact, this can never happen. Potential is exactly 0. This can never ever happen. Think about it. Why? This cannot happen. Not possible. This is not possible for gravity, because no matter how many masses you take, and let's say you are standing at some distance from these masses, if you find the net potential due to 1, due to 2, due to 3, 4, doesn't matter, each term will always be negative. Your total sum can never be 0. Your total sum of negative numbers can't be 0. You need at least one positive number. This is possible in electrostatics, not in gravitation. Because in electrostatics, you can have positive voltage also, negative voltage also. In gravity, you always get negative potentials. So no matter how many negative numbers you add, you will always get a negative number. It will never be equal to 0 or even positive. Is that okay? Is that right? Everyone with me? Clearo? Very, very important concept which many students get confused, especially with regards to gravitation or even electrostatics. Same question in electrostatics, this would be possible only because of positive negative charges. In gravity, it's always attractive, negative, so it is not possible. So that's the reason why you can see potential is not 0 at the center. These are important formulas. Talking about hollow shells, again very similar to electrostatics is what I would say. There are two situations over here. First situation is when you are inside. Next situation is when you are basically outside. The first situation is when you are inside versus when you are outside. It's completely different. It's completely different. It's a hollow sphere. Hollow means inside is empty. You have scooped out everything, only outer covering is there. Or a shell. It's a shell. Okay. So in such cases, what to do? When R is less than R, first situation, basically you are inside the shell. And second is R is more than R, basically you are outside the shell. Outside the shell. Then the formulas go like this. When you are inside, the field is always 0. Yes. If you are inside, each mass will pull you, but all the forces will cancel out each other. No matter where you stand inside, it will always cancel, and that's why the net field comes out to be 0. But when you are outside, let's say over here, then this entire shell behaves like a point mass at the center. It's like one point mass here, and you are finding the field at this point. So it will be nothing but just Gm by R square. It's like a point, like a point mass at the center. It's like a point mass at the center. Very, very crucial. Lastly, talking about potential. When you are outside, it is very simple. It is just minus Gm by R, because it will behave exactly like a point mass. So you assume this entire mass of the shell is concentrated. All the mass is concentrated at the center. So because of that point mass, what is the potential here? Minus Gm by R. That's all. That's the formula. When you're inside, that potential will be a constant. It is minus gm but by capital R. Please remember, this is going to be a constant because it is capital R, the radius of the, it is the radius of the shell. Capital R is the radius of the shell. Be careful. Got it? Everyone? These are very, very important for shell problems. Usually the shell problems are not common in gravity, but they are more common in electrostatics. Okay? Not in gravity. Similarly, solid sphere. Solid sphere can come in gravity and also in electrostatics. This is common. Ring also comes. Shell problems are little rare in gravity, but still I have given it to you. Again, there are two cases. Like I said before, if you are inside, that is R is less than R, that is one scenario. And then when you are outside, and then R is more than or equal to R. These are the two scenarios. When you are outside this particular thing, this is mass m, it could have some radius, let's say R, it could have some radius, let's say R. So when you are outside, the field is just given by gm by r square, is like a point mass, and even the potential is just like a point mass, so minus gm by r. You treat the entire solid sphere like a point mass over here at the center. Yes. Vishal, Newton's law was discovered, you know how many years back? In 1700s. How many years? 300 years. So 300 years old. Why should we study Newton's laws? Getting my point? Understood, Vishal D? Alright. Next, when you are inside, then comes the challenging part. If it was a shell, it is 0. But for a solid sphere, it is not. In fact, it is gm small r divided by r cube. It is proportional to r. It is proportional to r. Is that clear? Yes. Thank you. Love you, someone. Someone I love. I love someone. Nice. Okay. For potential, the formula is slightly weird. You put minus, you put g, and you put m. Those are standard things. But here, what happens is, you put the number 2 and put cube. Put 2 and cube. Here, you put the number 3 and put square. 2 cube, 3 square. That's all. And put brackets over here. That's it. Here, what comes is 2r cube. 2r cube. Here it becomes 3r square. 2r cube, 2r3, 3r2. And here you put minus and then you put small r square. That's the only difference. That's the only difference. So it is slightly complex when you are inside a solid sphere and you're trying to find the potential. Okay, great. Very, very important formulas. Also, the graphs of these things might come sometimes. Like for example, they might ask you the graph of, let's say, field versus distance. For a shell, it is inside 0, then suddenly becomes 1 by r square. So it is 0, then it is 1 by r square. That change happens at r. That is for the field, for the shell. For potential, it is constant, then it is inversely proportional to r, but it is negative value. So if it is potential versus distance, it is a negative constant till r, and then it goes like this. Remember, in electrostatics, this graph was on the top because you usually take positive charges. In gravity, please remember the graphs will be negative for potential. That's why I've shown it below the horizontal line. Common mistake done by many students. They forget to put it down. One option will be there like this. It will be like this. And many students will mark this option. They will get negative marks. So be careful whether it is a question of gravity or whether it is a question of electrostatics. Same way over here also for what is this? Field and potential. Field and potential. For solid sphere, this is field. You can see it is proportional to r inside and it is inversely proportional to r square outside. So it is proportional to r, inversely proportional to r square. So it is going to go like that. Okay, it increases and then starts decreasing beyond r. And if you talk about potential versus r, inside it is a quadratic equation, so parabola. Outside it is just inversely proportional to r. So the quadratic equation that you get looks like this, and then it goes like that. So that point of inflection is exactly at r. So it is a parabola over here. It is a parabola over here. Why is it a parabola? Because you can see quadratic term, and here it is inversely proportional to r. So it becomes a hyperbola over here. It becomes a hyperbola over here. Okay. So these are certain things which you should know. These are certain things which you should know regarding graphs. So maybe we can start solving some questions. A ring is lying at a distance of √3r from the center of a sphere, just below the sphere as shown, where r is the radius. Okay, from the center of the uniform sphere. Okay, the gravitational force by the ring on the sphere is, when you have a sphere and a ring, who can you treat as a point mass? Many students get confused. You might think that this question is easy, previous year question only it is. Again, I have taken it from these books which are there for all of you. Make sure you're using these books in the last few days so that you practice all varieties of questions with regards to the new pattern. If you solve very old questions, it might be slightly outdated. So try to solve the new questions. So in these cases, remember, it's always the sphere which can be assumed like a point mass. If by chance you take the ring as a point mass, you will get a wrong answer. Ring can't be assumed like a point mass because there was no such formula only for a ring. When you solve the formula for the ring, I never took the ring's mass is assumed here, or else it would be just gmm or gm by x square. Why would all this nonsense come? So you cannot assume the ring as a point mass, but yes, the shell and the spheres can be assumed like a point mass. So that's the reason why I will take this sphere as a point mass, and this distance is √3 times of r, and this is that ring of certain mass m and certain radius r. Now you can use your formula to find the force. I will multiply mass with the field. Mass is m, field due to the ring. This field is due to the ring. Standard formula, gm x. X is basically √3 r divided by r square plus x square. R square plus x, x is √3 r. So √3 r whole square whole raised to 3 by 2. Do the math, you will get the answer. gmm √3 r whole thing divided by r square plus √3. √3 square is 3. 3 plus 1, 4. So this will become 4r square whole raised to 3 by 2. Take the root first. So it will become gmm √3 r divided by 2r whole cube. So this will become gmm √3 r divided by 8r cube. So r and r gets cancelled. √3 by 8 will be there. √3 by 8 is only there in this option D. √3 by 8 is only there in this option D. You can see one of the r also gets cancelled and becomes 2, becomes square. Yes, that is option D. Yes, Gayu, that is the correct answer. Yes, Kishore, you will be taking the sphere as a point mass. Many students take the ring as a point mass. J aspirants, we want to prepare the units and dimensions or any other chapter, please go on YouTube and search Shreyas Sir Ray Optics, Shreyas Sir Units and Dimensions, Shreyas Sir Electromagnetic Waves. You'll get as many lectures as you want. Some lectures are short, like one shot, precise. Some lectures are lengthy, depending on whether you have time or whether you want to go in the full length manner or whether you want it as one shot. All kinds of options are there. So please make use of it. Okay, search button is there. Please use that. Okay, because in this limited time I'm trying to do as many chapters. See, I came on this channel and I made sure that we deliver as many chapters as possible, physics, chemistry, maths, in these last 25 days. Okay, otherwise, you know, if I would not have done that, then you will just be dependent on just some old videos which I know you will not search. I wanted the high weightage chapters to be for sure done on this channel. I wanted all these chapters to be done by all of us for all of you, so that at least you get high weightage marks. The remaining chapters, I hope that this will motivate you and push you to watch towards the other lectures and other videos also in the due course. And we'll prepare again for main second attempt. We will have more time. Okay, so don't worry, my dear students, keep watching all the classes. And I hope you are showing your love by smashing the like button. And if you have not yet subscribed, please do that. An object is allowed to fall from height r above the earth, where r is the radius of the earth. Its velocity strikes the earth's surface, ignoring air resistance, will be. Okay, all right, come on, think about it. What do we do in this particular question? What do we do in this particular question? Can you draw the diagram, my dear warriors? Can you draw the diagram, my dear warriors? Think about it. How will the diagram look like? How will the diagram look like? This is the 12th question. Open your book quickly. Open your book quickly and see the 12th question from this particular book quickly, everybody. So, if the object is allowed to fall from a height r above the earth, so this is that mass, this is that r, this is that r, this is from the surface. We know the center is here. This is the center, this is the mass, this is also r. This is right now at rest. By the time it hits the surface of the earth, it will be like this. This is r, this is m. This mass will be having certain speed. Let's say v. This mass will be having certain speed. What law, principle, formula will you use? Energy conservation, right? Energy conservation. No, there is no formula for this. There is only energy conservation that you can use. Yep, please use conservation of energy. Conservation of energy. That's it. Conservation of energy. So, my dear students, initially it had some potential energy as well as kinetic energy. Finally, it has some potential energy and some kinetic energy. So, what is the initial kinetic and potential? Potential wise, this solid sphere can be treated like a point mass. This point mass and this point mass are at a distance of 2r. So, can I not say it is minus g into m small m divided by 2r? Kinetic wise, it is at rest, so 0. Finally, when it reaches here, it's like a point mass is separated by a distance of r from this point, because the whole sphere can be assumed like a point. So, won't it be minus gmm by r, and final kinetic energy will be half mv square. You can see many terms might get cancelled like m, and m. I think I can shift this guy over here. So, I will just get v square by 2 gm by r minus gm by 2r, which will be half gm by r. This will be v square by 2, 2 cancels. So, v will be root of gm by r. V will be root of gm by r, but answers are in g, no problem. I can do one thing. I can write it as gm by r square into r, maintaining the equality. I know gm by r square is small g, so small g into r will be the velocity. Small g into r is IIT Bombay. Yes, that's the correct answer. That is the correct answer. Clear? Yes, JEE aspirants, correct. Very good, Hasni. Very good, Praveen. Very good, J. Shanmugaraj. Very good, Harni. Yes, Abhinav, you had to use energy conservation. Very good, Gayu. Yes, Harni, we had to use energy conservation. Correct, correct, correct. Awesomeness. You cannot use kinematics. Please don't do that. Why, Shanmugan Raj? Think, why can't we use kinematics? This is a very good question you asked. Good you asked it here, and you will not do that mistake in the exam, because acceleration due to gravity is not constant for such large heights. This is the radius of the earth. For small heights, till 1-2 kilometers, it's okay. 6,400 kilometers, that G will change. Kinematic equation is only applicable for constant accelerated objects, not otherwise. Very good. This brings me to escape velocity. So when you throw something, it increases the speed when you as it comes closer to the surface. So if I throw something from the surface, as it goes far and far away, the speed reduces. As it goes far and far away, the speed reduces. So just imagine from the surface of the earth, I throw an object, the speed is reducing because kinetic energy is getting converted into kinetic energy, and finally it stops, and then it returns back, Let's say I throw it with slightly lesser speed, maybe it will hardly go up by a small amount, and then it will return back to the surface. If I throw it with slightly more speed, now maybe it will go even far away, and then maybe it stops and returns back to the surface. What if Pandu told Champa, I don't want to see you again, and Pandu threw Champa into the air with a good speed, so that even if her speed reduced, it never became zero, ever. It never ever became zero. That means Champa never returned back to the earth. So Champa escaped the earth. She said bye-bye. Permanent breakup happened. So that is basically your escape speed. My dear warriors. And this escape speed formula is root of 2gm divided by radius of the planet. A very, very important formula. The escape speed for Earth is approximately 11.2 kilometers per second. Yep. Also remember, if escape speed of a planet is more than or equal to speed of light, then it will turn into a black hole. Because if escape speed is more than speed of light, meaning you have to throw an object more than the speed of light, which is not possible. So nothing can escape that planet's gravitational pull. It is very dense, very strong gravity. So that would be called as a black hole. Is that clear, my dear warriors? Also, this escape speed, remember, is independent of few things. Can you tell me what is it independent of? Look at it carefully, the formula. Look at it carefully. Hello Gracie, welcome. What is it independent of? It is independent of the projectile mass. Projectile's mass. And also the angle of projection. It doesn't matter whether you throw it up or 30 degree, 40 degree, 60 degree, doesn't matter. Angle of projection also. None of these terms matter. Okay, so these are the two independent things. Yes, very nice. Moving on to some questions. Escape speed for a body projected vertically upward from the surface of the earth is close to 11 kilometers per second. So if it is thrown at an angle of 45 degrees with the vertical, the escape speed will be 22, 11, 11 root 2, 11 by root 2. Come on. This I think everybody should spam. The answer. What do you think the answer should be? Come on, my dear warriors. Think. Yes, very good. B. It is independent of the angle. Doesn't matter. It really doesn't matter. No matter what the angle is, it will still be the same. Correct. Moving to the next one. Ratio of the escape speed of Earth to the escape speed of some other planet whose radius and density are twice as that of the Earth. So let's see. Escape speed formula is root of 2gm by r. There is no density in it. So let's get it in terms of density and then start doing the actual problem. Without that, I will not do. So what is mass? Mass is density into volume. So this will become 2g by r. Density is rho, volume is 4 by 3 pi r cube. R and r cube cancel, it will become r square. So it will become r root 2 4s are 8 pi by 3 g rho, correct, divided by r. Sorry, r is gone. That's it. Yes, that's all. So escape speed is r root 8 pi by 3 g rho. That's all. Interesting. Now radius and density. Radius and density. You can see that right over here, that escape speed is directly proportional to r and also proportional to the root of density. So hence, what will I do? Velocity of the planet, velocity of Earth by velocity of the escape for the planet will be radius of Earth by radius of planet and density of Earth upon density of planet. The radius is double, so this is 1 by 2. The density is also double, so this is also 1 by 2. So this will become 1 by 2 root 2. 1 by 2 root 2, where is the answer? Come on, my dear warriors. 1 by 2 root 2, where is the answer, my dear warriors? Is it not D for IIT Delhi? How many of you wrote that Delhi? No, it is not D, it is Delhi. Yes, be careful. Be very, very careful, okay? So it is IIT Delhi, my dear warriors. Right, black caps. Okay, moving on. A black hole is an object whose gravitational field is so strong even light can't escape. I just told you. What is the radius of the Earth so that it can be made into a black hole? Interesting question. Because I want the Earth to be compressed so that it becomes a black hole, that means the escape speed should be c. Escape speed formula is root 2 gm by r. This will be c. Square both sides. So 2 gm by r will be c square. So r will be 2 gm by c square. So therefore r will be 2 into 6.67 into 10 to the power minus 11. You have mass, which is approximately 6 into 10 to the power 24, and c square. What is c square? 3 into 10 to the power 8 whole square. Check out how much is approximately the radius. Check out how much is the approximate radius that you get after solving all of this. Come on, my dear warriors. I think you should get it close to 10 to the power minus 2. Close to 10 to the power minus 2 meters. 10 to the power minus 2 meters is 1 centimeter. Almost 1 centimeter, my dear warriors. So if you compress the Earth close to 1 centimeter, then it will become a black hole. Awesome. Haritnam, do you want more tricks? Do you want more tricks for Tukka and Guess? If you want it, then please like these videos. Yeah. If you don't like the videos over here, then why will I feel like doing some extra thing for you? No? So smash the like button, share, talk about the channel. If I see something really good happening in the comments, in the likes, in the subscribers, why not? I will do it for you. I'll give you some special tricks for cracking JEE Mains with guesswork also. Okay, I have some special tricks for all of you. Okay, chalo, let's go ahead to the next one, and that is acceleration due to gravity. Cool. So the acceleration due to gravity on the surface of the Earth is almost same everywhere. It's almost same everywhere. Some places it is different. We'll talk about it in a bit. And the value comes out close to 9.8 meters per second square. The value of G, acceleration due to gravity, is almost 9.8 meters per second square on an average basis, which you approximately call it pi square, which you can also approximately take it as 10 meters per second square also. Pi is 3.14, 3 square is 9, 3.14 square is close to G. This is an approximation which you can always remember. Now, this acceleration due to gravity depends on how high you are from the surface. It depends on what depth you are from the surface. It also depends on the rotation of the Earth, and it also depends on the shape of the Earth, and there are some, other variations which happen. So we'll talk about it. But before going ahead, let me tell you the value of acceleration due to gravity on the surface, which came out to be 9.8, is having a general formula of Gm by r square. Standard thing which I had also used in other places. Gm by r square is on the surface. This is on the surface of a planet. Any planet you take, mass of the planet, radius of the planet, and g, universal gravitational constant, will give you the acceleration due to gravity on the surface. But many people do not know the confusion which happens for height and for depth. Let me be very, very clear. If you go down, you are at some depth, let's say d. This is the center, this is the radius. This is, let's say, small r. This is, let's say, small r from the center. Then the acceleration due to gravity at depth d is given by gravity on the surface, 1 minus d by r. You can use this, or you can also use gm small r divided by capital R cube. This will also work. This will also work. One and the same thing. What is small r? What is small d? Everybody understood this? What is small r? What is small d? Everybody understood? Small r, my dear students, my dear warriors, it is from the center. It is from the center to this point. You are inside the earth at a depth d. So d is basically your depth from the surface. From the surface. If you want to use this, this is also okay. This is the distance from the center. This is the distance from the center. Please mind it. Okay, keep this in mind. Yep. You will get the slip in just few days. Don't keep searching. See guys, what happens is I can also start making videos saying, and advanced intimation slip, city slip will come tomorrow. I just got the news in this paper that the slip is going to come. News sources say that the admit card will come just few days before. Once I made the video, it's enough. I will not make it again and again. Many people will keep making it every day because students are going to search for it. It's up to you whether you want to waste time searching for it or whether you want to utilize that same time searching for a topic like, say example gravitation or whatever, limits, permutation, combination, organic chemistry, inorganic chemistry. So utilize that time. I know your heart will be or mind will be somewhere else saying, where is that slip? Is it coming tomorrow? Let me check. Relax. Whenever it comes, I will be the first one to tell you. Else I can make a video every day also and say that it is going to come, it is going to come. Waste of time. No point. Okay. Don't worry. All right. Then, if you talk about acceleration due to gravity at a height h, the formula is something like this. Gh is equal to gm divided by at height h. That means from the surface you are at a height h. This is the radius. It is r plus h whole square. This is the formula. It's very similar to this. Gf by r square. Here it is just r plus h whole square. But in a special case, this GH formula looks very similar to this formula and it looks like this: G 1 minus 2h by r. But this is not exactly equal to, this is approximately equal to, and only when h is much smaller than r. Like 300 kilometers, 500 kilometers. You can use it because 300-400 kilometers is much smaller than 6,400 kilometers. Is that clear, everyone? I hope this is very clear. Harinam, I like usually mechanics the most. I also like relativity and those concepts a lot, like the modern part. Not that modern part which is there in your books, but the real modern physics. It's very interesting. The wave nature, particle nature, that's very interesting in physics. Yeah. So did you understand? This is approximate formula. This is exact. It will work for even small height, large height. This will only work for small height. But there is that number 2 over here. Here there is no number 2, and this is the exact formula. If you see, equal to is there. Here equal to is not there. This is approximate for small height. So be careful about all these things, else you will make some stupid mistake. Okay? Great. Now, this was ideal scenario. But in reality, what happens? The gravity is slightly different at different places. There are actually 3 reasons. I have listed down 2 of them here. I have just listed down 2 of them here. One is the shape, one is the rotation. I'll tell you the third one orally. The Earth is not a uniform solid sphere. Our JEE assumptions are very miraculous. We always take uniform solid sphere. Where is Earth uniform? Somewhere there is mountain, somewhere there is snow, somewhere there is desert, somewhere there is water, somewhere there is more iron. The Earth's core is different density, Earth's outer crust is different density. So the layers are there, materials are different, so it is not uniform. That's one of the major, or I would say one of the contributors for getting slightly different value than what you get theoretically. Is that clear? Due to variations in density, due to non-uniformity of the density. The next one is rotation. If you rotate anything, you are thrown out. So that gives you an apparent weight concept. If you are on a merry-go-round, you are thrown out. Or if you are on a vehicle which is going around a curved bank or curved track, you are thrown out. Same way, every person on the Earth is literally thrown out, but Earth is not rotating so fast that people are thrown out into the space like, mad fools. No, that effect is there, but it is less. But that also contributes in the small variations. So if a African man is standing over here on the equator, he will be at the largest distance from the axis, so he will be thrown out the most. So he will experience very less gravity because gravity acts down and he is thrown out. Gravity acts down but he is thrown out. So the gravity that he feels will be slightly less than a penguin right over here. If there is a penguin right over here, it is on the axis, there is no centrifugal force only on the axis. So the penguin on the North Pole or the South Pole, that will not experience any pseudo force or centrifugal force. That will experience true, gravity. So that effect is given like this. If you are at a latitude, this is your equator, this is the point where you are at, this is lambda, latitude angle. Lambda is latitude of that place. You remember geography, you have studied longitudes and latitudes, that's the same latitude. At all these points, the latitude will be the same, correct? So the formula is G prime, or the change in the gravity that you get because of that, the new gravity is G prime, is G into 1 minus omega square r cos square lambda. If you are wondering what this omega is, it is the angular speed of rotation. Angular speed of rotation of the Earth. That's the formula. You can see if lambda is 90, meaning you are at the North Pole. North Pole, lambda is 90 degree, G prime will be G. Even at the South Pole, lambda will be minus 90, G prime will be G. It's only at the equator that lambda will be 0, cos 0 is 1, cos 90 or minus 90 will be 0. So this term will vanish and it will become G only at the poles. At the equator, you will get the least gravity. Yes? Why I said African? Because Africa is near the equator. No, that's why. Okay. No other thing. So if you are going to nice destinations in Africa, right, where you go to see maybe the wildlife in Africa, or you go to see the beaches in Africa, so you will see that your weight over there will be slightly less as compared to the weight had you gone to the North Pole or South Pole, only because of the rotational effect of Earth. But that difference is very less. Don't expect that you will see 2-3 kilos different. Okay, cool. So how many of you have been to Africa? Have you been? I have been to 2 African countries, and I was blessed to see 2 African countries, and it was very, very nice. Yeah. But yet to see the wildlife over there. Yes. Yes, the safaris. And oh, some of you have been. Great, 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 great. Flat earthers are very disappointed. Wow, Praveen Kumar, you have been to Africa. Wow, very nice. Okay, so what about variation in acceleration due to the shape of the earth? That is because the earth bulges out at the equator. It's fat at the equator and it is slightly smaller at the poles to pole distance. So because it is flat, it is ovalish shape. Because it is ovalish shape, not so much, it is exaggerated. So pole is closer to the center. Pole is closer to the center, whereas the equatorial points are far away from the center. So that's why the gravity is less over here. And because you are closer to the central mass, the gravity is more over here. That's the reason for that. Yes. Oh, I have been to Seychelles and I have been to Mauritius. Yeah, both these places. Both are, towards the right side of Madagascar, eastern side of Madagascar island. Okay, so we have seen all the variations. Now comes the graph of how the acceleration due to gravity will look like. How the graph of acceleration due to gravity will look like as compared to the distance from the center. This is acceleration due to gravity. If you are inside, just look at this formula. It is proportional to r. Distance from the center, it is proportional to r. So basically, the graph will look like a straight line. And as soon as you reach the surface, it is maximum. After that, it is inversely proportional to r square. So directly proportional to r and inversely proportional to r square. That's how the graph looks like. In fact, it is maximum at the surface of the planet. Maximum at the surface of the planet. Yes, I hope this is very clear. Okay, okay, very good, very good. All right, somebody is singing Samyana Waka 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 hey. This is the time for Africa. Oh, nice. Find the depth and the height from the surface of the earth where acceleration due to gravity is a half of its value at the surface. Find the depth and the height, both. So first let's find the depth. The depth is very simple, which is half the value at its surface. So gravity at depth d is g by 2. The formula for gravity at depth d is g into 1 minus d by r is equal to g by 2. G cancels. So 1 minus d by r is 1 by 2. So d by r is 1 minus 1 by 2, which is 1 by 2. So d will be basically 2 times of r. This is the first part. This is the first part. So 2r, sorry, not 2r, my bad, r by 2. How can depth be 2r? R by 2, my bad. So r by 2 is there in option A, option B. So C and D naturally get eliminated. Next, for height, do not use g1 minus 2h by r, because who says that the height will be small? It could be more also. So be careful. So gh is g by 2. Gh is given by gm by r plus h whole square. This is g by 2. But g value we already know is gm by r square. This 2 is as it is. So this g, I have put it as gm by r square because I can cancel gm. So take this on the top, this will become 2r square. Take this on the top, this will become r plus h whole square. Take roots on both sides. So r plus h is root 2 times of r. So h will be r common root 2 minus 1. That's it. That is the second answer. Root 2 minus 1, which is option A, of course. There we go. Yep. Very nice. Great. Santosh, very nice answer. If you clear marginally Harithanam, you will just get that satisfaction of clearing mains, but NIT you will not get. Maybe some private college you might get. NIT to no. Okay? So there is no point getting 91 percentile or even 92 percentile or even 93 or even sometimes 94. Very few NITs, that too lower branches, and all the low ranking NITs you might get, that too not a good branch. Otherwise it is very difficult. Okay, cool. Next question from JEE Mains 23. The weight of a body on the surface is 18. The weight of a body at this altitude above the surface is how much? Okay, this is a special value. Like you can see, 3,200 kilometers is 6,400 by 2. 6,400 by 2. So 6,400 by 2 means R by 2. All right. So gravity at height h is a formula gm by r plus h whole square. Since g was gm by r square, so gm will be gr square. So instead of gm, why not put it as gr square? Just put it as gr square. And here this will be r plus h will be r by 2 whole square. So what will happen? This will become gr square. R square is also common. 1 plus 1 by 2, 3 by 2. 3 by 2 square will be 9 by 4. R square cancels. So 4 by 9 g. 4 by 9 g. So that is your g at height h. That means the weight at height h will be 4 by 9 times the weight on the surface. What is the weight on the surface? 18 Newton. 18 by 9, 2 4s are 8. So answer should be 8 Newton. D for IIT Delhi. D for IIT Delhi is the answer. How many of you wrote it? Yes. Yes. Great. And let me also tell you, my dear students, just because you get 90 percentile, don't lose hope. Okay? Do you think that everybody will get 99 percentile or 98 or 96 or 97 percentile? No, right? Hello Anugna, nice to see you back. There will be lakhs and lakhs of students who will get 95, 90, 60, 70, 80, 40, 1 percentile also there will be one student. Correct? There will be some student, some legendary student will be there somewhere in this country or outside the country who will be getting even 0.1 percentile also. Just that nobody will know that person, or nobody will bother about that person. Nobody will talk about that person. But maybe just after 10 years or maybe 15 years or maybe even 5 years, who knows, maybe that person only does something really remarkable in life. Right? Who knows? That maybe that person who got even 20 percentile in JEE Mains might be a very differently talented person. Maybe that person has a talent in maybe finance, maybe in arts, maybe in singing, maybe in something else. And someday we will see that person somewhere, maybe in the newspaper or on the TV, or maybe, in our friend circle, and we'll be like, oh my God, this person does so well, he's earning so well, oh my God, he does this, he earns like that. And we'll be like, okay, did he clear JEE Mains? Oh, maybe not, or maybe. And it doesn't matter then. So don't worry. That's all I would say. Don't worry about all these things. Right? So these are just your tests. And this is not just the only test you will have in life. Your board exams is just one small test. Your JEE Mains is just one small test. JEE Advanced is just one small test. Your life will throw many tests at all of you. So you have to clear many tests. You will fail in some. You will fail in maybe n-1 test, but maybe you will pass in that one test, which will mean a lot for all of you. So, just have hope and don't lose that hope even if you get less marks. That's all my advice would be. Right? So moving on to the next one coming up on your screen. A particle performs SHM when dropped inside a tunnel, a diametrical tunnel. This kind of question is very common. It has come in previous year's JEE Mains also. Yes, it has come in previous year's JEE Mains also. So how to do these kind of questions? So if you dig a tunnel, what happens is that mass, okay, so let's say there is some Pandu over here. and that Pandu decides, okay, I will jump into this tunnel, that Pandu will get accelerated towards the center, of the earth. By the time you reach center, the gravitational force will vanish because it will just cancel out. But by the time you reach the center, you have some speed, so that speed will take you over here. But as you start going down, then gravitational force will be opposite, and that's why your speed will reduce and you will stop over here. Again, you will start going here. Again, you will go here. Again, you will go here. Again, you will go here. You will keep on oscillating back and forth. So that is your simple harmonic motion. That is your simple harmonic motion. Right? So how to find the time period of that simple harmonic motion? You take a mass m, and let's just assume that the mass m is at a distance x. I hope you can see that x. At a distance x from the center, and the radius of the planet is, let's say, r. Let's say the radius of the planet is, let's say, r. Okay, I hope you can see that r. Trying to write it. Cool. Okay, so at that particular point, what will be the force of gravity? What will be the force of gravity? That force of gravity will be the mass into gravity at that depth. And the gravity at that depth, I can use the formula gm into distance from the center, which is x, by r cube. Remember this formula? I had given you two formulas for gravity at depth d. I am using the second formula. If you have forgotten, let me just show it to you. See this. Gm, r, distance from the center, by r cube. That's all I am using. That's the same formula. Now just rearrange this term. It will become gm small m divided by r cube into x. This is f. Isn't this looking like f is equal to kx? Isn't that k? Isn't this like the spring force? Isn't this like the spring force? And the time period of a spring mass system is 2 pi under root m by k. So in this situation, what will be the time period? It will be 2 pi under root mass by k. But here the value of k that you will get is gmm by r cube. Is gmm by r cube. Mm cancels, so you will get 2 pi root r cube by gm. That's the value of the time period. 2 pi, okay, root r cube by gm. Brilliant, right? Yes. Yes, Shastra is good. Shastra is good, definitely. But not the best, I would say. But yes, it is decent enough college. Great. Let's go to satellites. Last few things are remaining. So satellite is any body which rotates around the Earth due to the mutual gravitational pull. And that gravitational pull, the force of gravity provides the centripetal acceleration for the uniform circular motion of the satellite, right? That's what happens. So the satellite has certain speed where it goes around. Maybe I can take the radius of the planet as r. I can also say that the radius of the orbit is small r, where only this much is h, which is the altitude of the satellite. Altitude is always measured from the surface. Radius of the satellite's orbit is smaller, always measured from the center of the planet. V is the orbital speed. V is the speed with which the satellite goes around. And this gravitational force is the force which is giving the centripetal acceleration. A satellite can be of many types, like natural and artificial. Natural is the one which is naturally formed. God made it. And like the moon, right? Hey, Kepler PCM, you remember me, Yusuf, but sadly I don't remember you. Oh my God, who is this guy? So guys, yep. Moon is the natural satellite. Artificial satellites are the ones which you send via rockets. And these artificial satellites have different purposes based on how they are made to move. Say for example, this is your planet. This is the equator. This is the axis. If A satellite goes in the equatorial plane, something like this, in the equatorial plane, so that wherever you are, the satellite is always above you. The satellite is always above you. Okay, so you are here, the satellite is always above you, always above your head. That is called as a geostationary satellite. Geostationary satellite whose time period of orbit is 24 hours. It takes 24 hours exactly in sync with the Earth. It is geosynced with the Earth because it is always above you. Isn't that right? Yep. Very good. Satellite portion deleted. Just check, my dear warriors. Okay, I'm just doing it just in case if it comes in some way or the other. Okay, the next one is polar satellites. The next one is basically polar satellites, where the satellites go from North Pole to the South Pole. From North Pole to the South Pole. These are called as nothing but polar satellites. Okay, and the last one is basically a satellite which goes very close to the surface of the Earth, very close to the surface of the Earth. That is called as a surface satellite. Surface satellite. That means the height is much smaller than the radius of the Earth. Now, what are the formulas which you should know? Orbital speed, speed of the satellite's orbit will be root gm by radius. Root gm by radius, that's the first formula. Okay, block this off and keep. You should know this. They might ask you indirectly also, and also from JEE advanced point of view, or maybe in BitStat it might come. That's the reason why I'm doing it. Yes, yes. So please do the satellites part from BitStat or other exam point of view. Time period of a satellite. Time period of a satellite is 2 pi root of r cube by gm. That's the formula. Keep this in mind again. 2 pi root r cube by gm. And lastly, energy of a satellite, very important. The total energy of a satellite is minus gmm by 2r. Sorry, 2 small r. 2 small r. And the kinetic energy is negative of total energy, and the potential energy is twice the total energy. This you have also seen in atomic structure. This you have also seen in atomic structure for Bohr's model of atom. Okay, so the same formulas are also applicable over here. Same formulas are also applicable over here. Yes, called calculation of potential energy inside the sphere. I think I just did that potential inside solid sphere. Please look at it. I gave a big formula, God of football. 2, 3, cube. I just gave you calculation of the potential inside the solid sphere. I gave that. Yeah? Okay? Okay? I hope this is very clear. I hope this is very clear. Awesome, awesome. Yes. Now, these formulas, like I said, are very much similar to your, atomic structure. So if you know that over there, you know that over here also. I hope this is understood. Cool. Let's solve some questions based out of this. Starting off with this one over here. The radius of the circular orbits of two satellites A and B of the Earth are 4r and r respectively. If the speed of the satellite A is 3v, then the speed of satellite B will be how much? Speed of the satellite B will be how much? Come on, my dear warriors. Figure this out. Figure this out. Come on, quickly. What do you think is the answer? Which formula are you going to use? A and B, the radius of the orbits are given. If the speed of the satellite A is 3v, then the speed of satellite B will be how much? Speed of the satellite formula. Use that. Speed of the satellite formula. What is it? Root of gm by r. Don't you see the speed is inversely proportional to root of r? Speed is inversely proportional to root of r. Correct. So, speed of satellite B upon speed of satellite A will be radius of satellite A, radius of satellite B inside the root. I want to find speed of satellite B. Speed of satellite A is 3 times of v. It is clearly mentioned what is the radius of A. radius of A is basically 4r, radius of B is r. It's A by B on the top, remember. So RR cancels, root 4 is 2. So VB will be 2 multiplied by 3V, which is nothing but 6 times of V. So 6V is IIT Bombay. Yes, 6V is nothing but IIT Bombay. Okay. Awesome, awesome. Is that clear? Is that clear? Awesome. Okay, okay. Awesome. Very good. Let's move on to the next one. Next one. The additional kinetic energy to be given for a satellite going around a planet of mass m to transfer it from circular orbit to another radius r2 is how much? To another radius r2 is how much? How much additional kinetic energy you need to give? Remember, kinetic energy is just negative of the total energy, correct? So in the first case, if I calculate kinetic energy, total energy is minus gmm by r, 2r, sorry. So that minus sign will go away. So it will become minus gmm by 2 times r1. Second time, it will be gmm by 2 r2. So that the difference of the kinetic energy, what will it be? gmm by 2. Here you will have 1 by whatever that r2, sorry, 1 by r2 minus 1 by r1. That's all. Or 1 by r1 minus 1 by r2. So I just put modulus over here. That's it. So I think it should be this one over here, which is option number D. Yes, that 2 is there and you have 1 by r2 minus 1 by r1. The mod of it, whichever is bigger, whichever is smaller. Simple? Right. Moving on to the next one. If escape speed is V, orbital speed is VO, then how are they related? Oh my god, such a tricky question. No way. It's such a simple question. Orbital speed is root of gm by r. Escape speed is root of 2 gm by r. So if you divide the two, VO by VE, root will, gm r will cancel. So I'll just have 1 by 2. So basically VO into root 2 is equal to VE. Escape speed is root 2 times orbital speed, which is option D for IIT Delhi. Yes, how many of you wrote it? Very good, Black Apps, Hasni. Yes, Samia. Yes, Santosh. Very nice. Moving on to the next one. And that is, I think we are coming to Kepler's laws. The last part of this. Let's just have a look at it quickly because it might be important maybe from BitStat or CUET and other such exams point of view, EMSAT and so many other exams. Okay. Maybe in mains they don't ask so many questions on this, but still I'm doing it for you just in case it comes. Just in case. First of all, understand what is this Kepler's law used for. What is this Kepler's law used for? If you have a very heavy mass at the center and you have a teeny mini mass which is going to go around it, then you can use Kepler's laws. Like the sun and the earth, sun and the Jupiter, sun and the Mercury. Sun is very heavy, Mercury, earth, Jupiter, etc. are very small as compared to the sun. So that's when you can use Kepler's laws. If there are two suns or two planets of similar masses, then you can't use Kepler's laws. The first law says that if the heavy mass is kept at the focus, then the smaller mass will go along the elliptical orbit. Or if a planet is going in an elliptical orbit, then the massive body around which it is going will be at one of the focus of the ellipse. Remember, for an ellipse, this is the major axis, this is the minor axis. This is the center. There is one focus F1 here, F2 here. Nothing is there at F2. Only at F1 you will get one sun. That's all. I hope this is clear. Is that right? Everybody with me? Awesome. This is the first law of orbit. The second one is the law of area, which says that if you draw a line from the massive object to the planet, and you see how much the line goes and how much area it covers in some time, how much that line covers in some time, how much that line covers in some time. That is going to give me area, and divided by time will give me something called as areal velocity dA by dt. Areal velocity, which is dA by dt. This areal velocity is a constant according to the second law, meaning the area swept per unit time is same. So when you are very far away from the sun, because this length is more, you can see this base of the triangle is less, so it will hardly move anything. But when you are very close, to sweep the same area in the same time, you will move more distance so that you cover the same area. That is the meaning of areal velocity is constant. So when you are close, you are fast. You are very fast over here. And when you are far, you are basically very slow. And this dA by dt is angular momentum by 2 times of m. Angular momentum by 2 times of m. This L is angular momentum, and this is a constant since it is conserved. Angular momentum is always conserved of any planet which is going around the sun. It does not change, it is constant. So hence dA by dt is also constant because the mass 2 and L, all the things are constants. Keep these things in mind. Yes, I hope this is clear. And the last one is the law of period. I don't know why the number 2, it should be number 3. That is, if this is the ellipse and this is the semi-major length, this is major, semi-major, then the square of the time period is proportional to the cube of the semi-major length. This is for ellipse. This is for ellipse. But if it is circular, orbit, then the radius only is a. Hence, time square is proportional to r cube for a circular orbit. The radius itself is the semi-major length. That's why it is proportional to r cube. And if you remember the time period formula for a satellite, it was exactly like that, whatever we saw over here in Kepler's laws. You square both sides, t square you will get over here, you will get r cube over here. It's directly proportional. T square is directly proportional to r cube, which is consistent with Kepler's third law, of course. Okay, is that right, everyone? Let's do some questions based out of it. The orbital angular momentum of a satellite is L when it is going in a circular orbit at certain height from the surface. If the distance of the satellite from the center is increased by 8 times to its initial value, then the new angular momentum is, I think this was supposed to be r over here, yeah, not h. So if the distance of the satellite from the Earth center is increased by 8 times to its initial value, then the new angular momentum will be. So read the question again and again, you will understand what formula you might have to use. First time, circular orbit, height r from the Earth's surface, meaning this is actually 2r radius in the first situation. In the next situation, the distance of the satellite from the Earth center is increased by 8 times of its initial value. So basically, this distance becomes 8 times of its initial value. That means if this was 2r, now this has become 8 times of 2r. 8 times of 2r. That's what it is. So in a way, you can also write it like this. Let's assume that this radius was r, doesn't matter. Then this will be 8 times of r as per the given information. Okay. Now, question is, what is the new angular momentum going to be? In general, angular momentum of a satellite which is going to rotate will be mass into radius into velocity. Mass is mass, radius is radius, velocity is root of gm by r. R will cancel, so you will get this as m root g capital M into small r. Root r will cancel, root r will remain in the numerator. So angular momentum is directly proportional to root of r. So L2 by L1 will be root of R2 by R1. Correct? Root of R2 by R1. The distance of the satellite is satellite from the Earth center is increased by 8 times. Yes. Oh, the increase is 8 times. The increase is 8 times. That means the actual distance is not 8r. It is 8r plus r. That means it will be 9r. This word by 8 times is very important. I increase the money in my bank by 8 times. Meaning if I had 100 rupees, I increased it by 8 times. So I added more 800 rupees in the bank. So it became 900 rupees. Is that very clear? Is that very clear, my dear warriors? Hello, Chetan. Yes, very good. So what will happen over here? R2 by R1. R2 is 9R. R is R1. So root of 9 is 3. So L2 by L is 3. So L2 will be basically 3L. So where is 3L? Option number A. Option number A. Yes, that is the correct answer. A very tricky question. Many people can make some silly mistake over here. Next one. The distance between Sun and the Earth is R. Duration of the year if the distance between Sun and the Earth becomes 3R. JEE Mains 2022. I hope you are using the book. I hope you are using this book. Okay, it's there in this book, the previous year book. Okay, the link is there also in the description box in case you have missed it. Yes. How do we do this question? The distance between the Sun and the Earth is R. The duration of the year if the distance between Sun and the Earth becomes 3R will be. Use the Kepler's third law. T square is proportional to R cube. So T2 by T1 whole square will be R2 by R1 whole cube. The distance has been made 3 times. So this is 3. So 3 cube. So that will be, 9, so 27. So that will be T2 by T1 whole square. So take the root on both sides. So this will become T2 by T1 root of 27. This will become root of 27, which is 9 into 3, which is 3 root 3. So T2 will be nothing but 3 root 3 into T1. But T1 is 1 year. So this will be 3 root 3 years. 3 root 3 years. Yes, option D. Yes, option D. This kind of questions have come in JEE. Very good, Gayu. Very good. Chaudhurapu. Very good, Harni. Awesomeness, awesomeness, awesomeness. Now there is a very, very important announcement for all of you. Especially if you are near Delhi. There is a simulator exam where you will actually feel like you are entering the exam hall. You will get the feel of writing the test on the computer, people entering the hall on the computer, not on a paper. That is called as a JEE exam simulator with a very special JEE mains test, exactly like the replica of your actual paper. So if you want that special mock test, please make sure that you fill up the form, because this is going to happen in between these dates. You just have to fill the form. Just like you get an intimation slip, you will also get a slip, and you will be asked to come to the exam hall at this and this time. You will get the actual feel of the examination. It is from 8 to 11 and 12 to 3 and 4 to 7. These are the 3 times where you will get it. It will be conducted at the Vedantu Learning Center in Janakpuri. It's in Delhi, New Delhi. Okay, you can see the address is right mentioned over here. It's only for very few entries, because the center is not very big that 1,000, 2,000, 3,000 students can come at one go. Understand that? So only few entries will be taken. So as you are watching this video, make sure that you fill up the form which is there in the description box. In the description box, you can see, where is it? Yes, register now for a mock test. There is a form. Just open the link. JEE Exam Simulator, Janakpuri, New Delhi. Experience the real feel of JEE exam environment. Email, name, mobile, city, when would you prefer, and submit it. That's all you need to do. Okay. And if you want to buy the previous year books which I was showing you over here. Okay, this book if you want to buy, then click on this link. It's there on Amazon. You can buy either physics or chemistry or maths or combined all of them. Okay, this previous year book is just there for how much? 1,499. Okay, free delivery is also available and it will come by January 17th. You can still make use of this book for your second attempt also. So these are the two important things which you should be all aware of. And as you have completed the lecture, make sure you put it up in the comments. Gravitation done, done. Gravitation done. Just put it up in the comments. I would be really happy to see that. I hope you guys enjoyed the class. Yes, awesome. Me watching from Chennai. We'll be coming to Chennai. We'll be coming to Andhra. We'll be coming to Bangalore and so many other places also very soon. But for that, we need to make sure that the only JEE English channel in the country becomes popular. The only JEE. Yes, you can search it anywhere on YouTube. This is the only JEE English channel, and I want to continue serving all the students who need me and the team. So make sure that you talk about this channel. We want to ensure that this channel becomes really worthy and enables students to get their desired ranks, their dream ranks in the near future. Okay, and that will be the happiest and the proudest moment for all of us back over here. So let's make sure that this channel becomes popular, because there are many Hindi channels, but for many students, especially in the south or maybe sometimes even in the northeast or in some metro cities, you need that English touch because you know you have been studying in English medium and higher studies and jobs and all that, you will be doing it in English. So put up a comment, smash the like button, also hit the subscribe. Thank you so much. It means a lot for coming over here, and see you now tomorrow for the sure shot power-packed marathon which is going to run for physics, chemistry and maths by me, Paul sir and Namrata ma'am tomorrow. Okay, sharp at 5 o'clock, be there on time. And Saturday there is going to be a very special grand launch for the last final lap of revision for your JEE Mains. Be ready for that as well. It's a short sweet session where we'll announce some crazy plan for all of you. Okay, bye bye, take care. Hasta la vista, Captain Shreyas signing off. Take care.